Hi, everybody. In this particular video, I'm going to talk about sampling. Now, sampling versus the population, sampling frames, things of that nature. Uh, it has a natural application to survey research, which is why I usually link it there. But the concepts themselves are useful in many contexts. So I will share my screen and we'll go from there. So the first thing that I'd like to talk to you about is differentiating between a sample and a population. So when we use the word population, the word population refers to all parties of interest, all individuals of interest. Now, researchers define their population. So if I were to define my population as all students in my research methods class, well, that population is easy to attain, right? However, as the population increases, it gets harder and harder to access the whole population. So let me show you what I mean. I started with all students in my research methods class. Let's say I wanted to study all students in any research methods class at the college. If I were to do that, then it gets harder, right? Because I may or may not have access to another professor's students to fill out a survey. But let's say that I work through the registrar's office and they manage to get me all people. That's a lot harder than my students, but still doable. Let's say I wanted to study all students in a research methods class in any college in the United States. Now it becomes very, very impractical to do that. So as the number of individuals grow, it becomes harder and harder to access the population as a whole. So what do? Typically, we use samples, and a sample is a subset of the population. So if the population is all parties of interest, a sample is some, but not all parties of interest, right? It's a subset of the population. Now, if done well, samples can approximate the characteristics of a population fairly reasonably. So making sure you have a representative sample is going to be important. So all the important characteristics of the population should be reflected in a sample. If done well, that's wonderful. Now, we say it's an estimate of the characteristics of the population because it's not everybody, so we can't say it's a complete depiction. But with statistics, we can determine the probability of getting an outcome. We could determine through reproducibility and potentially with a certain sample size generalize to the population, right? So there are sample size plays a role in generalizability, representativeness plays a role, and we're going to talk about sampling frame too. So let's talk about confidence intervals. Confidence intervals, you'll see this on many psychological tests. So this is the percentage or confidence that the true population lies within that sample. So you might see plus or minus 10%, plus or minus 5%, plus or minus 3 or 2.5%. And that is your margin of error, right? So in IQ, you might see a confidence interval of 95, and then it says plus or minus, I'm making it up, but 7 IQ points. So if that's plus or minus 7 IQ points, if a person got an IQ of 110, what we're saying is that we are confident that their true ability is anywhere between 103 and 117, right? So that's what the plus or minus does. Now, when we have samples, we do plus or minus in percentage. Now, what we see in general principles, the larger the sample size is, it results in a reduction of the confidence intervals. So the plus or minus percentage gets smaller as sample size increases, because as sample size increases, it approximates the population better and better. And here's the cool thing. At a certain point, it actually plateaus or levels out. So we have a great deal of confidence when we have roughly 1,000 participants, that assuming that it's representative and reflects a sampling frame, if you have 1,000 participants, we have a great deal of confidence that reflects a population. So let's take a look. Now, I talked to you about precision of the estimate or confidence intervals. So these are your plus or minus in the percentage, right? So plus or minus 10%, plus or minus 5%, plus or minus 3%, right? As the size of the population increases, in general, the sample size that you need to have that 95% confidence interval also increases, right? Now, also, as the precision of the estimate increases, when you allow a smaller margin of error, the sample increases. So if you look, if we go from right to left and go down the 10%, as the population increased, the sample size needed to increase, right? If we go down the 5%, plus or minus 5%, as the sample size increased, as the population increased, the sample size needed to increase. And go down to 3%, same thing, it always increases, right? Now, I said going down, that tells you as the population increases, keeping constant the precision of the estimate, the sample size has to increase. Now, let's go across from right to left, not down. So let's take a sample of 2,000, right? Or a population of 2,000, forgive me. If you wanted to have 95% confidence in your sample with a precision estimate of plus or minus 10%, you only need 92 participants. If you want to reduce that margin of error, it goes to 322. If you want to reduce it further, it goes up to 696. It remains true that as the population increases, your sample size increases, but as the precision of the estimate increases, the sample size also has to increase. So the margin of error drops. All right. But you'll notice that even over 100,000 participants, or a population of over 100,000, 1,000 participants would be fine. So let's look at that, the ratio of the population. So to have a plus or minus 3% precision of the estimate, you need about 700 people. So that's about a third. But if the population's over 100,000, all you need is 1,000. So roughly 33%, roughly 1%. So I want you to think about that, and sometimes even less than 1%. So as sample size increase, confidence intervals decrease, that's in general. But at a certain point, sample size plateaus at about 1,000. That's what this graph is supposed to show you. Now, when we talk about sampling techniques, there are two basic sampling techniques, and each of them have several subtypes. So I'm going to define them in principle and then go through them. So we have something called probability sampling. Probability sampling is when you know the likelihood of an individual being chosen. Now you'll notice the specific probability of being chosen must be known. Now we want probability sampling when we're trying to have precise statements about the population or trying to generalize to the population. Sometimes we don't know the likelihood of a person being selected, right? That's called non-probability sampling. So our generalizability in non-probability sampling is reduced, but that doesn't mean it's not useful. So non-probability sampling still can be useful. So let's talk about the three types of probability sampling. So probability sampling, simple probability sampling is where everybody has equal likelihood of being selected. What would that look like if I were doing research and I was going to select someone from a class to be my research assistant and publish with me? And I put everybody's name in a hat. And everybody's name in a hat once, right? So everyone has equal likelihood of being selected. And I know how many names are in the hat. That's simple random sampling, right? So to be clear, simple random sampling is, you know, the probability of being selected. So let's say there are 30 participants or 30 students in a class. You would say 1 out of 30. And you know, each person has one chance. So that's simple random sampling. Now, stratified random sampling, we use stratified random sampling when we understand that there are different proportions of a group of interest in the population. So if there are subgroups within the population of interest, right, we have to make sure that our sample is proportionate to the population. So we divide into stratas or subgroups based on that. So we want to match our sample according to that demographics variable. So if we're looking at ethnicity, we would look at the proportion of the group that's white, Black, Hispanic, Native American, and so forth, right? All of these options would be listed, and I would make sure that whatever my sample size was, the percentage is equal. That's stratified random sampling. Now, I still must know how many people I'm drawing from. That's why it's probability sampling. And I still must know the likelihood of being selected, right? But now it's just matched according to strata. Now, cluster sampling, now we're not looking at individuals, but we're taking a whole group and all of its participants. So a good example I like to do is, let's say I wanted to study favorability ratings of graduate students in clinical psychology. Well, we know how many clinical psychology programs are in the country. We know how many people every year the university must report how many people they entered into their program. So we know how many people are in each program. Now, cluster sampling would be, let's say I wanted to study universities, but I said, hey, maybe the experience at one university is different than another. So I kind of want to take all the students in a clinical psychology program, in a doctoral program. Now I have to take all of the members. So stratified random sampling makes sense. So, but let's talk about cluster sampling. So at the top, let's say I had 6 schools. The first one would be, I don't know, City University of New York Graduate Center. Second one would be Teachers College, Columbia University. Then Rutgers, then LIU, then Hofstra and Pace, right? So now I have 6 schools. Now, obviously, if I were doing a large scale study, I would do it throughout the country. But if there are 6 schools and I know I'm drawing from that, once I draw that school, I have to study all of the members. So I said number 1, and I'm not going to remember all of them, but number 1 I said was City University of New York, right? So once City University of New York is drawn, I have to give the survey out to every single grad student in the clinical psychology program at City University of New York. It's not that I'm selecting an individual from City University of New York, but every person. And then I think I said number 6 might have been Pace University. So all of the students there. And that's how we do it. So now we're taking clusters, we're taking a group and all of its contents, all of its members, and giving a survey out. So all 3 of these are probability sampling, right? Because we know how many schools there are, we know how many people are in each school, and we know that then we can calculate the probability of each member being selected. Now, the definition of probability sampling was that the likelihood of being selected is known. Non-probability sampling was the likelihood of being selected is unknown. And the most common non-probability sampling that we have is called convenience sampling or haphazard sampling. Haphazard or convenience sampling is just taking volunteers, taking what we can get. So let's say you stood outside the library and you didn't go in and count all the people, but as people are coming out of the library, you say, hey, do you want to fill out a survey? And some people volunteer, some people say no. Now, do you know the likelihood of the person who said yes being selected? The answer is no. So most research is actually done with convenience sampling, where people just voluntarily sign up to your study, but you don't know the total likelihood of being selected. Now, purpose of sampling, you have pre-established criteria that must be met in order to be eligible to participate. So that would be in your eligibility requirements, but you have an agenda for your research, so they have to meet that require. But if they meet that require, anyone who volunteers can participate. You don't know the likelihood of being selected again. And now you may remember we talked about stratified random sampling. It's very useful, but there is a version in a non-probability technique called quota sampling. So again, you don't know the likelihood of an individual being selected. It's haphazard, but you still match the proportion of the population in your sample based on the group of interest that you're matching it on. So these are the 6 sampling techniques. Now, here are some challenges with haphazard or non-probability sampling. You could introduce error or bias. You could run the risk of not being able to generalize. Now, notice I said probability sampling was essential if you want to generalize to the population. And, some considerations, not putting restrictions on how individuals are chosen or put into subgroups could interfere with your interpretation of the results as well. So here's a breakdown of advantages and disadvantages of all 6. Now, when we think about samples and populations, I said it's very, very important that you have a representative sample. A representative sample means that all the essential characteristics of the population are also in the sample. Now, there's a term related to that called sampling frame, which is you conceptualize the population and then you evaluate how well the sample matches the population. Now, here's the deal. Very rarely is it a perfect match. Very rarely do they coincide perfectly. So the effect of not aligning the sample with the population or not being within the sampling frame could be minimal or it could be consequential. So you have to be very careful talking about how you sampled and talking about the impact of that. And you're going to talk about sampling in your design section of the method, right? So you're going to talk about how you solicited participants. Now, another thing we want to think about is response rate. Now, response rate is specific to surveys. So if you give out a survey, you mail out 100 surveys, and you get back 10. How confident are you that those 10 responses reflect the 100 people of your population? Probably not that confident. So the lower the response rate, the more error variance, the more bias you could have. Now, we talked about whether you wanted to have surveys face to face or mail them out. Generally, mailed out surveys have lower response rates than telephone surveys. As a rule of thumb, I always tell people to aim for about a response rate of 30%. If you get a response rate of 30% or higher, then it's adequate. I wouldn't say it's amazing, and there's still potential that that sample doesn't reflect the population, but it's adequate. So mailed out surveys have lower response rates than telephone surveys. Think about that when you're designing it. How do we get the response rate up? Well, there are many ways to do that. One is send a letter that accompanies or is sent out prior to the survey explaining, hey, in this packet, you have a survey, or in the upcoming week, you're going to receive a survey, and that survey is measuring X, Y, Z. So giving an explanation for the survey is going to be important. People are on the lookout for it now that they know it's coming. Sending follow-up reminders, whether it be by mail or phone. Hey, by now you should have received a survey. The survey is due back in 3 weeks. If you misplace your survey, please contact us and we'll send you another one. You know, reminding them or resending it. Sending personal stamps are much better than business reply. Number one, prepaid postage in general is better than expecting them to pay for postage. But if you're gonna prepay for the postage, the personal stamp and personal signature of the letter, actual ink, shows a connectedness or investment in your work. So people are more likely to fill it out if it has the personal stamp, personal signatures. Offering incentives, gift cards, raffles, prizes, etc. And then, you know, if people aren't sure whether to participate, making sure they understand the value of the research. All of these increase response rates. Now, so if convenience sampling has downsides, like, you know, it increases bias, it potentially can't generalize out to the population. Why use convenience sampling? Well, it's cheaper, it's more efficient, it's quicker. A person may want to just know if a relationship exists with and whether you know, there's a pattern in the data. They may not want to generalize to the population. And oh yeah, it still is possible with a large enough sample size that it could be representative and reflect the population. So all of these are reasons for convenience sampling, using it in spite of all the downside. So that is my very brief lecture on sampling techniques and sampling versus the population. So I'm going to stop there. Take care, everybody.